Hello everyone, welcome to the semicolon. In this tutorial, we're going to learn about activation functions. So, according to Wikipedia, activation functions are something which maps a particular output to a particular set of inputs. So, they are used for containing the outputs in between 0 to 1 or any given values. They are also used to impart a nonlinearity, and they are one of the important factors which affect your results and accuracy of your models. So it is very important that we learn about it. So these are some famous activation functions: identity activation function, binary step activation function, logistic or sigmoid, which we had seen in the last tutorial, the tanh activation function, arctan, ReLU, leaky ReLU, and softmax. So we'll be looking at what each of this does. So identity function is as simple as this. If you have x as your input, it gives you x. There's nothing big in it. So this is the graph of it, and whatever your curve is, you'll get the exact same curve. Now binary step function, if your input is greater than 0, it gives you 1, and if your input is less than 0, it gives you 0. So it takes all the positive input and makes it 1, and all the negative inputs and make it 0. So this is the binary step function. It is very useful in classifiers. When you want to classify it between 1 and 0, then this is very useful. Then we have our logistic or sigmoid, and what this does is whatever your input is, it maps it between 0 to 1. So even if your input is as large as thousands or lakhs or millions, it will map it between 0 to 1. So that is very useful in neural networks, because when the input goes out of 0, it may start to increase exponentially, which may be a problem. So it contains the input between 0 to 1, which is very useful. Now we have tanh activation function, which contains the function from -1 to 1 and is similarly useful to the sigmoid function. You can try out between tanh and sigmoid and check which accuracy is better and use it accordingly. So this is the tanh activation function, 2 by 1 plus e power minus 2x minus 1. And this is the arctan function. This is just the tan inverse of x. So even this contains the number between somewhere around minus pi by 2 to plus pi by 2. So even this is kind of replaceable and alternative to sigmoid or tanh. It does a similar task. Now we have ReLU, which is a very popular one when it comes to deep learning and even normal neural networks. So what it does is whenever your function is less than 0, it gives you 0, and whenever it is greater than 0, it remains as it is. So what it does is it removes the negative part of your function. And now we have leaky ReLU, which does a similar job, but it doesn't make the negative input 0, just reduces the magnitude of it. And then we have our softmax classifier. So this is used to impart probabilities. When you have 4 or 5 outputs and you pass it through this, you get the probability distribution of each. And this is useful for finding out the most probable occurrence or the classification where the probability of a class is maximum. So these are some famous activation functions which are very useful and play an important role in deciding the accuracy of your model. Whenever you have a doubt that this activation function might be better, it's always better that you use it and test the accuracy, because you never know which activation functions will give you the best accuracy. So that's it for now, guys. If this tutorial helped you, hit the like button, click on the subscribe button if you want to keep watching. Thank you.